Hey folks, welcome back. It's Mr. Drew again. We're going to move on with our properties of matter unit, and today we're going to be talking about how we can use those properties of matter to describe whether something is physical or chemical. So go ahead and take a look at this material here called Aerogel, and what I want you to do is have your notes packet ready and use two of the words from our properties list to complete the following question. Can you describe this new material using at least two of the properties that you learned in this packet, in this unit so far? Let's take a look.
That is only a few times the mass of the same volume of air, which kind of makes sense because it is 99.8% air. In fact, some aerogels are so light that if you removed all the air from them, they would be less dense than air. I have long been fascinated by aerogel, so I actually flew out to Aerogel Technologies in Boston to find out, why was aerogel invented? How is it made? Why is it such a good thermal insulator? And what is it used for? Okay, we are going to try an experiment to demonstrate the insulating power of aerogel. So over here we have two setups, one with a glass petri dish and the other one with aerogel on top. Both are made of silica, but with very different physical structures. We're going to see how long it takes to melt these chocolate bunnies with a Bunsen burner. Now to have a look at this experiment, we have a FLIR T1020, which can see temperatures up to 2,000 degrees Celsius.
Yeah, you can see that. The glass is getting really hot already.
And after just a minute...
It's starting to smoke.
Oh, okay.
It's definitely melting and smoking. Oh, yeah, here we go. I would say that that's phase change. We've got liquid chocolate situation. We have some smoking bunny. Over here, the bunny is actually sort of melting over, and look, it's sort of tilting to the side. I think we're going to call that melt.
What is that?
Oh, on cue. I would say that that's material film.
Not only did the bunny melt quickly, the petri dish cracked under the thermal expansion. So now let's try the aerogel. So how was aerogel invented?
Back in 1931, a guy named Professor Samuel Kistler had a bet with his colleague, Charles Learned.
Now the bet revolved around jellies, like peanut butter and jelly jellies. And the thing about jellies is they are actually a combination of liquids and solids. I mean, they're mostly liquid, but it's embedded within this 3D solid structure.
So if you think of a gel like Jell-O, has a skeleton with nano-sized pores that gives it its rigidity, and then that's about 1% of the gel.
So the bet was this: could you remove the liquid from the jelly without affecting the solid structure? I mean, if you just evaporate the liquid out, well, then the solid structure shrinks, because as you remove liquid molecules, they pull on each other, and they pull on the solid structure around them, basically crumpling it from the inside. Now, Samuel Kistler solved this problem in two ways. First, he realized you could replace one liquid with another inside the jelly just by washing it thoroughly. So you could swap out, say, water for alcohol. And then, if you take the jelly and put it in a high-pressure vessel called an autoclave, by heating it to the high-temperature, high-pressure point called the critical point of the liquid, that liquid transformed into a semi-liquid, semi-gas called a supercritical fluid. At this point, there is no longer a distinction between liquid and gas. Those molecules are no longer pulling on each other.
So once you depressurize the vessel, that solid skeleton, that 1% of the mass of the gel, is left behind intact, except for where there was liquid in the pores before is now gas. And that solid skeleton, that nanopore solid, is what we call aerogel.
Kistler published his findings in Nature in 1931.
It is getting pretty hot, as you can see through the thermal camera.
But coming up on 3 minutes, there's still no sign of melted chocolate.
So we're going to pull out a thermocouple and just check the temperature underneath the bunny, like underneath the aerogel, and see what the flame temperature is. You can kind of see that parts of the bunny are getting hot, but it's not the bottom of the bunny. It's all the around the bunny.
Exactly. That convective heat is moving up and around the aerogel.
So you can see the thing is getting red hot.
And by 4 minutes, the bunny's looking a little soft.
Pretty good, though, considering how easy it is to melt chocolate. Can I put my finger here? Careful. Not that it's hot, it's a grill. Right. But yeah, totally cool to touch, right? It is just warm to the touch.
Wow, that was pretty great. Aerogel seems to have some really distinctive properties. Do you have two yet? Make sure you have conductivity, or the lack of, as one of your properties. Aerogels do not transfer heat well, if at all. Why, those crayons have been under a flamethrower and they're not melting. If you'd like to see more of aerogel, just check in the video links for the rest of that video. Now, as far as homework goes, guys, especially if you're at home, you're going to be doing the How Matter Changes assignment. It's located in Schoology. There is a paper copy in your packet if you'd rather read it on paper, but you need to complete it in Schoology. The due date for that assignment is November 11th. Don't forget, you're still working on your superhero, and that rough draft is also due the 11th. And coming up will be a quiz on the properties of matter. That will be posted on the 11th, and it will be due on the 18th. So, got some things coming up. Please keep up to date on all of the assignments. Check Schoology often. Today we're going to find out the differences between physical and chemical changes. You're going to need your note packets, please. So, as we go over the physical and chemical changes in our notes, please follow along and fill in as we go. Okay guys, we're in our notes packet now, and we're looking at the word physical changes. As regard to properties of matter, we're talking about rearranging the position of molecules in materials. So we are changing them, but we do not make a new substance. A physical change can be reversed. Feel free to pause the video if you need to fill in your definition. An example of a physical change would be solubility. The molecules in sugar or salt can be rearranged as they're introduced to water. It looks like the salt or sugar dissolves in water, and you're going to notice that they almost look invisible. However, if you were to taste the water, you would definitely taste the sugar or salt, which are still there. They do not change into a new material. They're simply sugar in water or salt in water. Another classic example of a physical change is changes in state. What I mean by that is a liquid can turn to a gas or a solid, depending on temperatures. However, the material you started with is still the same material. The molecules are just either closer or farther apart. Changes in state do not result in a new material. Water is water in any state of matter. Chemical changes, however, recombine atoms into new molecules. These form new substances with new properties. And this cannot be reversed without undergoing another chemical change. An example of a chemical change could be something like rusting. A car left out over the winter time will actually change the material from iron into rust or iron oxide. The combination of oxygen with the iron creates a brand new material. Not so good for building cars out of. Burning, also a classic chemical change. The chemical reaction of the flame is actually creating carbon dioxide and water vapor, and you're not going to get the dollar bill back after it's burned. Reacting could be also a great example of chemical change. Things to look for: changes in color, smoke, or odors, or bubbling, like effervescence. Reacting materials together means the chemicals are creating a chemical change. Let's take a couple of examples and see if we can rank them in physical or chemical change. Crushing a can. When we crush a can, we're changing the shape of the molecules, but we're not creating a new material. Therefore, the change is physical. It can be undone. You could consider it just a change in shape. Fireworks, however, cannot be undone. This is an example of a chemical change. Anything with flame or explosions definitely creates a new material that wasn't present before. How about a melting ice cube? Is a melting ice cube an example of physical or chemical change? That's right, it's a physical change. It's still water, it's just in a different state of matter. Use the back of your notes, if you haven't noticed already, to write a C or a P to describe the changes in the pictures. Here's some burning logs. Burning, as we know, is always a chemical change. How about this picture? Mixing cake batter. We've added some eggs and some water, some flour, and some flavors. Have we created a chemical change or a physical? Well, since we haven't baked the cake yet, we haven't introduced a chemical change, we've just mixed the ingredients. When a penny rusts, a green covering or oxide is created. This rust in a penny, just like the rust in a car, is a chemical change. That new coloring is a new material that wasn't there before. If you've ever looked at the Statue of Liberty, you'll see a green coating. It was made of copper. How about the leaves changing color in the fall? Was that a physical or chemical change? At first glance, you might think physical, since all that's changed is the color. But if you ask yourself, how did that happen? Well, then you'd have to say it's a chemical change. The chemicals that make up the leaf combine with other chemicals to create the colors that we now see in the fall. That's not a change that we can undo unless we do another chemical change. One tip is anything to do with growing or living organisms as they change or even digest their food. Those are all chemical changes occurring within the cells of the organism. Okay, take a minute now and pause and see if you can classify each of the terms in your packet as either physical or chemical changes. Just put a P or C next to each of the choices. When you're done, go ahead and resume the video and we'll go over the answers. Welcome back. Let's take a look at the answers. Frying an egg would be a chemical change. Cooking involves the changing of a material that's very hard to undo. Once you've cooked something, you can't reverse that process. Dissolving sugar, however, still results in sugar. It's just dissolved in water. That's a physical change. Cracking an egg, simply physical. Breaking glass, it's just small pieces of glass. Lighting a match is a chemical change involving fire. Slicing bread is a physical change of cutting bread. How about boiling water? Physical change. It's still water, we've just turned it to a gas and boiled it. Baking a cake. The term baking should be a clue. When we cook something, that's a chemical change. Digesting food. You're not going to get the food that you digest with the acids in your stomach and being absorbed into your body back into a hamburger. It's a chemical change. Cutting grass, however, is physical. Melting of ice. Remember, guys, it's still water. That's a physical change. Same with evaporating water. Water can exist as a gas. It's called water vapor. Making a wire. Ductility. That's simply pulling a piece of copper into a wire shape. Rusting metal is chemical. Did you get them right? If not, go back to your notes and review. Use your note packets to draw your own example of 2 chemical and 2 physical changes. Make sure you label which is which. Here are some examples and things to remember when we talk about a chemical change. Not easily reversed, new products formed, reactants might be used up, you might not get them back. Often you'll see signs like heat, light, sound, or fizzing, even electricity. And you may have an example such as flammability. Physical changes, on the other hand, are reversible. No new products are formed, we have the same materials we started with. It's often just a change of state, like an ice cube melting from a solid to a liquid. Alright folks, I've gone ahead to Schoology just to show you the homework that's due. In our Properties of Matter unit, we have a purple folder called How Matter Changes. That assignment is due November 11th, don't forget. If I click on that, I'll find the reading which you also have in your packet. When you're ready, you're going to take the assessment, which involves the same 10 questions you see in your packet. However, you're going to do it right here on Schoology so that it can be graded. Make sure you do a good job. You get 2 tries at this assignment. So if anything happens, or any problems occur, or you didn't get the score you wanted, go back and do it again. Good luck.